Fast as always. And
while we wait,
and we are online on YouTube as well.
Hello, effect enjoyers. Welcome to another Effect Office Hours.
Hello. Welcome, everyone.
How is everyone doing today? So, Mattia and I don't have anything planned for today. So, hopefully, you folks came armed with things for us to look at, questions, etc. If you guys have anything you want us to look at, or I don't have time today, but I will be here in spirit. Well, you're already here, so there you go. Did we lose Mattia, or did I disconnect?
Oh. I think that, okay.
I think Mattia's back.
Are we live back? Okay. Okay, yeah.
I think you dropped for a second.
Bump. Yeah.
How was Effect Miami? Effect Miami was great. It was a really wonderful event that was put on by the community down there. They did a wonderful job. The space was beautiful. So again, big shout out to the lab down in Miami for hosting that meetup. Some really good conversations. Dax's talk was really fun to listen to. I'm sorry that my talk didn't end up getting recorded. I blame Mike for that one. We took a break between Dax's talk and my talk, and Mike interpreted that as me forgetting to start the recording, because that wouldn't be the first time that I've forgotten to start the recording. So anyway, I'll probably take one of the office hours is coming up and just do run through the slides that I did at Effect Miami. But yeah, Dax's talk was great. Ariel's talk was great. And I got good feedback on my talk as well, so it was fun. But honestly, the conversations and chatting with folks was the highlight of the event. And it was also cool because a lot of the people that I talked with down there were not necessarily using Effect already for day-to-day work or even at all. They were mostly I spoke with a lot of people who were genuinely curious about Effect and wanted to learn more. And so I got to kind of pitch Effect to a lot of folks who were kind of evaluating whether or not they were going to use it for upcoming projects or refactorings. And so that was a lot of fun. But yeah, so overall, it was a fantastic event. Just expect less high quality comments from me today. The bar for your comments, FIWS, is so low that I'm not really sure if we could get any lower. Let's see.
I'd love to get feedback on this Effect SDK I'm building for Rivet actors. Nice. Gonna wait for the link.
Hang on, I'm not what is up, blank space? What are we doing today? This is our weekly Effect office hours where we sort of chat about anything related to Effect and answer questions from the community. Sometimes we have guests on just to talk about the projects that they're building if we think they're interesting and useful for people to learn from. But yeah, this is really mostly just like an educational hour and a half that we do on a weekly basis for all things related to Effect. Yeah, Igor, we can definitely take a look at your project. There was another project there's another question in the chat about when to use Schema.struct and when to use Schema.Class. I've heard that we should use Schema.Class for domain concepts and Struct for the shapes of data. That's a fine way to think about it. However, especially in V4, I think there's a big caveat to be aware of. So let me share my screen and maybe we can, Mattia and I can talk about this before we actually look at other people's code.
Just wanted to say before we go on with the question, Igor, please send your link over Discord, because I think that, as always, YouTube strips out links. So I don't see the link for the repository. Okay.
So here's the V4 code base. Beautiful, effect small. Let's take a quick peek at Giulio's manifesto on Schema for V4.
You meant Giulio's book on Schema.
Yeah, his 7,000 line markdown file of everything related to Schema V4. And if that wasn't enough, there's also a migration document, although it's much. I actually referenced this one a lot more than the migration doc. Is it true that the effect license will change and require pay by yield, but only from open code? Actually, it's even more specific than that. It's pay by yield only for DAX and only for Kit. So it's gonna, especially for Kit, I think it's gonna get pretty expensive. And it's not just pay by yield usage, it's like pay by yield invocation. So definitely going to be a situation over there. All right, so let's answer this question about schema and then we can sort of move on. So I actually ran into this recently when I was helping a friend work on migrating to V4. Let me find. So I think the easiest way to get started with class-based structures in schema is to, if you have a struct schema, which again, a struct schema is used to model usually like a piece of information, like an object, similar to like Zod.object or Z.object in Zod. Mattia's espresso cup just rattled my American brain. Fair enough. Blank space, I will get to your question. So anyway, just to keep going on this schema question. So Schema.struct is used to model objects in schema. And you can turn a struct schema into like an opaque structure. So maybe I can even open a new CD effect small. And we can check out main, and I will make this bigger, don't worry. Pay by NPM download. Who needs VC money then? Indeed.
Indeed.
So let's take a look at this. So if we import, I think this is a worthwhile conversation because there are a couple of different ways to create class schemas in effect. So let's start with maybe like a common example of a structure you might model with schemas. We have a point which has a finite x coordinate and a finite y coordinate. Finite schemas are used to model numbers that are finite in JavaScript, meaning they don't. Finite does not represent numbers that are not a number, infinity or negative infinity in JavaScript. So this is basically like all finite numbers except for those three values. And usually when you define a struct schema, and let's just say like you're doing this in a library context or maybe a domain package in your application, you also want to define the type at the same time. So type of point.type. And this allows you to, when you're importing from this file, import point, and then you get access to both the type, the symbol point represents both the type and the schema. But some people don't like this, and like it's annoying to them that they have to declare a separate type for the schema. So an alternative to this which is I'll call like the plain struct pattern, right? Plain struct schema is to use Schema.opaque, opaque struct schema, which gives you class syntax. So export class point extends schema opaque point. I can type today. I always forget the syntax for this. Right. And then we basically just replicate the same structure here. And now point here is both the type and the value. So you still have the like actual methods on point that you can call. And then you still have the, because it's a class, and in JavaScript, a class is both the type and the like runtime object at the same time. So I'll call this like the opaque struct schema version, which is fine. And you can attach behavior here like you would on any other class. You can have like, you know, decode equals, sorry, static decode schema.decode unknown effect, this. And now decode would take an unknown and you get the effect back. So you can add like static properties, and that's nice. But if we go back to Julio's document for a second, there are actually other ways to do this that are maybe more robust. So let me keep searching for class. Keep going. Classes and opaque types. So let's get rid of this. So schema.opaque lets you take a struct and wrap it in a thin class shell whose only purpose is to create a distinct TypeScript type. Internally, the value is the same struct schema. Instance methods and custom constructors are not allowed, so there's no new. It's not enforced at the type level, but it might be enforced through the linter. So generally speaking, you don't want to like, you could do this, but you don't want to attach behavior to the these schemas if you can. This is the static side, which is fine. You can attach behavior to the static side, but you can't, like, there's no way for us to enforce like adding instance methods here, like I don't know, as string or toString, right? There's no way for us to enforce not doing this on the type level. So really, I think you should think of opaque struct schemas as just a way to take, let's call this like 0.2, because I want to retain these things. Because if you look at the type of point here, you get the full like object here. The difference with 0.2 is if we alias it for a second, you get an opaque type here, and opaque just means like you don't see the full structure, you just get like the pretty name. So that's the second way with schema you can define class schemas. But again, this is really just a like
type level
wrapper.
Trickery.
Yeah. Oh, it's type level trickery. It's an opaque wrapper around, you know, whatever. How is it different from Schema.Class? Schema.Class does other things here. You can add instance methods. You get automatically implemented equal. Instances carry the prototype, so instance of works. So like when you have, and Julio does a really nice job of like detailing all of this in this big giant schema manifesto. So like if you just want a pretty type and don't need any of the other fancy stuff that a class schema gets you, schema.opaque around a struct is fine. And like I said before, you can add static methods here. It's just instance methods that won't work. If we scroll down, let's skip recursive opaque structs. We don't need to look at this. You can add a brand to your opaque structs if you want to. This can be really useful for making it the type unique, because again, this is just type level trickery around this struct schema. So if you have the same exact struct schema, they'll be assignable to one another on the type level unless they're branded. So even though they have different like names, TypeScript treats these structurally the same, unless you have a brand in here. And this is kind of how you do it, how you can make the type unique with Schema.opaque. Now, you can technically turn any schema into a class now. And this was actually something I brought up to Julio a while back when Schema v4 first came out. In Schema v3, every single schema could extend, like you could every single schema was a class, so you could extend every like schema. You could do like class my string extends schema.string, and that would work, I think. You could extend unions, you could extend literals, you could like create a class out of any schema. In Schema v4, the internal representation of schema changed so to be much more flexible, but in turn, the internals are not like classes themselves, so you can't extend them. But Julio added support for that through this as class wrapper. And this is really just a convenience method thing that allows you to attach static properties and things that allow you to reference this. But there are like significant differences from Schema.opaque. It doesn't make the decoded type nominally distinct. It does not add equal or prototype-based features. It's literally just like when you do this, it's literally just a way to be able to add static methods to your schema. So it's even like a less robust class, if you so to speak. It's like just a way for you to be able to add maybe the decoders or something to carry the decoders and encoders along with your schema. But the real thing that I wanted to talk about, no, I didn't want to talk about this. Hang on. Where are you, Schema.Class? Here. Okay. The real thing that I wanted to bring up here is Schema.Class in v4. So this is the first, no pun intended, first class way to create a class-based schema in v4. And when you do this, you get the type, the class automatically implements equal for you. So you get like hash-based equality. It allows for static methods to be defined on it, and it also allows for instance fields to exist. So when you create like an instance of A here, it would have an _A property. And perhaps we can show this here with export class .3 extends Schema.Class .3, and we can just do this. So if I do read only A, then if I have const my point equals new .3, right? And I do my point.a, I have this available as an instance method. And you can add like methods too. So if you wanted like a static read only, right? Origin equals new this. I think this works. You could do const
origin.
.3 origin.
Yep.
Right. And again, you still have access to the instance fields. So class-based schemas are probably the most flexible and powerful in that they give you the ability to define instance methods, static methods on the class. They implement equal for you, and there's a bunch of other stuff that Julio kind of goes through over here. You can also brand classes the same way that you can brand opaque classes. And I really want to focus on this for a minute, because this is kind of where this is something that's been tripping people up recently, because we made it explicit in v4 and it was not in v3. So let's say you have like an HTTP API, right? Where you've got some HTTP API spec, HTTP API. HTTP API, HTTP API group, and HTTP API endpoint, right? Class my API sends HTTP API.make my API add HTTP group.make test. I think I can add an endpoint directly, but whatever, we'll just do it this way. And we'll just say, I don't know, this is a post endpoint testing. And we'll make this the root level path. And we'll have, I don't know, the payload is a 0.3. Right? So we've got a very, very simple HTTP API here. Let's just export it so the LSP doesn't yell at me. We got an HTTP API with one group that has an endpoint in it, and it takes a payload of 0.3. Or maybe even we can make this more explicit. Let's do this. Success. We'll say the return type of this endpoint, the response type is a 0.3. Right? So when we go to implement this, HTTP API group dot, no, sorry, hang on. Let's extract this test group. And now when we do the test group handlers, what is the word? Implement? No.
You think you need HTTP API builder?
Yes, that was what I'm thinking of. HTTP API builder.
Group.
Thank you. My API test handlers. So when we go to implement this, handlers.handle testing, if we were to just return oh my God. Succeed. I think this is the right syntax, right?
Yep.
What's the... Let's
remove.
Correct. So there's a really big problem here, which is that in our handler here, this shape satisfies the shape of 0.3, which means that it passes type checking. But at runtime, so at runtime, this will fail because this is not an instance of 0.3. So class-based schemas, to make them work, under the hood are implemented as transformations where we transform from the structure, just the XY like structure, into an instance of 0.3. So when you're decoding an object with the 0.3 schema, for example, schema.decode unknown effect 0.3, this here under the hood implements a transformation where first it will decode the structure, making sure that the structure conforms to this structure, and then it will transform that structure into an instance of 0.3. And so that's why on the type side of the schema, you get the 0.3 class as the type, like the actual instance type is the type of this schema. So this here will actually fail, even though we can't represent that at the runtime at the type level, because this is not an instance of 0.3. To fix this, you could either use a struct schema here. Obviously, that's not as flexible. The other way to do this is to have the class here. Whoops. Vim going crazy. But there is one parenthesis short. There is a way to fix this on the type level. And that's to brand the schema. So I mentioned before that like especially when working with the HTTP APIs, this is like a footgun that even I've hit. So I've made it a point to use this second brand type parameter pretty much all the time when working with my class-based schemas. I forget what Julia worked on as a brand. And all you have to do is this. And now we'll get a type error here because property brand is missing in here, but required in 0.3. And now if I change this to an instance of 0.3, this will pass type checking and it'll eliminate that silent footgun. So this was like a really long-winded way of explaining this and like trying to get to this point. But I think class schemas are exceptionally useful in V4. They're very flexible. They're more flexible than they were in V3 even. But we should all be aware of like the footguns, and that's why like branding them at the type level I think is almost required, especially if you're using your schemas in the context of like an HTTP API or an RPC API. Why isn't that the default behavior? Because we can't brand them. I don't think we can brand them by default because you have to declare a unique symbol like at the declaration point. There's no way for us to do it by default. I don't think.
Basically, TypeScript takes that unique symbol declaration location and uses that as an identifier for the actual value of the unique symbol. And so that's something that needs to live in the code where you declare the classes. Otherwise, we cannot do that. Because if we would do that, that means that we would like reuse that for all of the classes.
Right. We could consider making the second type param mandatory. Yeah, Mike, we could. I think that it's worth consideration. I'm not sure it's like the right move, only because I think there are like valid situations where somebody might not need the brand and might just want to use these, like maybe in the context of a CLI, whatever. But even then, like I think there are valid situations where you hit this footgun, and so having this brand here makes sense. How does that differ from the identifier 0.3? It doesn't differ per se. It just attaches this brand as a TypeScript unique symbol to the 0.3 symbol. So 0.3, like this symbol still exists in TypeScript, but now we have this kind of like fake property that exists that's completely unique in TypeScript.
I think it was referring to the 0.3 string that we have to pass in for the identifier. That one, yes.
Got it.
That one is not used anyway at type level. That one is used internally. If I recall correctly, that's an identifier that's used mostly to allow things. If I recall correctly, you can have let's say that you have ESM and you end up with duplicated like class definitions that are basically the same. If I recall correctly, that identifier is used so that two classes from the same identifier,
let's see if Julio talks about why we need the identifier. It also uses I think that by default, class schemas use this identifier in like error messages, I think.
Yeah.
I forget, maybe Mike remembers the exact reason. I forget the exact reason why the identifier is necessary. This can be whatever. And usually with these identifiers, like I kind of default to making them the package path, but Mattia's LSP can actually just generate them for you. And there's like, if you look at the LSP documentation, he walks through how you can customize that behavior as well, which is nice. This way you don't even have to like really worry about this. But the brand itself is just a fake type level property.
Definitely, we need a rule for that. I'm pointing that we need a rule that if someone wants to opt in that behavior, a rule in the DSP that triggers when you have schema classes without that brand defined.
Even, I mean, that kind of depends on whether or not we make this mandatory.
Yeah. If we don't. Yeah.
Could that identifier be used at the type level as a pseudo-esque brand? I don't think so, because you can't guarantee that it's globally unique in a TypeScript program, whereas unique symbol will always be unique within a given TypeScript program. Yeah, so that is... Hello, Matt Simpson in my Twitch chat. I've got my Twitch chat and my YouTube chat open. Let me scroll back and just make sure that we didn't miss any. Actually, there's one last question here. You guys are smarter than me, but I just see added complexity to make classes work with schema, but I'll need to revisit a few times. I don't really see the argument there. maybe I'm just too used to this, but like most of, like, especially if you have the LSP installed, most of this syntax just gets generated for you. Like my schema class extends Schema.Class. Like the LSP generates this for you. And then that's it. Like, and again, like Matthias said, we could enforce this at the type level, or we could enforce this from the LSP. But I don't really see, especially if you don't consider brands, like this is just a class that is backed by a schema. That's it. And this identifier is used for a few things under the hood, and that's why it's required. Yeah, also this has absolutely nothing to do with schema. Classes are problematic in TypeScript. Agreed. This is like all of these things we're talking about are ways that we're trying to guard against how weird classes become, like, to deal with in JavaScript. Like if classes behaved a little bit more consistently or had a little bit less strange behavior in JS, like most of these things would be unnecessary. Like we wouldn't need this self parameter if TypeScript was a bit smarter about inferring this on the static side of the schema, and we also wouldn't need the identifier. Like there's just like, ergo my comment above about why use classes. Just if you don't like them, don't use them.
Just use the opaque or just the struct. And
yeah, there is no requirement to use classes. The only benefits in my mind that like you get by using classes are you can attach custom behavior, which I do think is useful. Like you can attach custom methods that allow you to, same way you would on any other class in JavaScript, you now have a schema that the instances have access to specific methods. The type, you don't have to separately declare the type, right? The type and the runtime symbol are one and the same. So, I mean, I think there are valid use cases for using class with schema, and I think they do have quite a bit of power attached to them. But if you don't like them, just don't use them. You don't need to.
For example, one use case could be, for example, if you define schema class error, you can, for example, define getters on the class error to automatically construct the error message based on values that are stored in the class without having to construct them at instantiation of the class instance. You can store on the class only the properties for the actual error that has happened, for example, a tag and the HTTP status code, and then you can define a get message and construct your HTTP API has failed with the error, etc., etc., etc. And that way, when you log your causes, you will get that error as well. And also other things like custom equality or whatever that can be defined. It's something that you can get with schema classes. You cannot get with schema structs unless you like perform your own transforms after you have used the schema struct. But again, then you are basically recreating a smaller version of schema class.
Yeah, I think the two arguments for using classes in my mind are, Number one, like Mike mentioned in the chat, classes are the only way in TypeScript to get both a runtime value and a type at this in one shot. Otherwise, you have to declare the type separately like this. Classes are the only way to get runtime type and TypeScript type at the same time. So you avoid this boilerplate. And then secondly, it's extremely powerful to be able to co-locate behavior associated with your domain type inside that domain type. So instead of having a struct here point and then saying export const, I don't know, right, like flip the x and y coordinates, or invert, maybe a better name, whatever. Instead of having module scoped methods to do this, you can have that behavior exist directly on the class. You can attach custom behavior to things to transform values of the class, like Mattia was talking about. So there are like valid use cases for using classes in JavaScript with schema. Classes in v4, model supremacy. Model's a whole nother conversation, and it's still technically experimental, so, or unstable, so won't be talking about that right now, but yeah, and so there are very like valid reasons to use class. I think the main two that are easiest to understand from like a beginner perspective are co-locating domain specific behavior with your domain type and avoiding the boilerplate of having to separately define the type here. Because like if you forget to define the type and then you try to use it somewhere else in your program, then you have to go back, you have to define the type. It's like very annoying to have to remember to do this all the time. So there are valid use cases. Let me scroll back. There were more questions that I missed. Not effect related, but which Neovim? I swear, somebody asks me this every single stream. The plugin that I'm using that generates these little brackets here is from Snacks in Neovim. It's called Snacks Neovim. I forget the particular module. It's one of these. Maybe it's the indent scope. And then I have, yeah, it's the indent scope. And then I just have like a custom characters for the indentation. Wald, Matthias, if it's still not clear, please let us know. But I think that hopefully we answered the question. There were a lot of questions. Hang on. Why would one not use Schema.Class over Schema.opaque, even if they don't need instance methods? Wait, why would one? Sorry, there's a lot of like double negatives here. Let me read this without the double negatives. Why would one use Schema.opaque over Schema.Class if they don't need instance method equals, etc.? Perf, opaque appears to go against v4's goals of reducing multiple ways of doing something. Opaque is literally only there to make the type opaque here. That is it. So there is like a, it's much less heavy. Like a schema class is a little bit heavier because it defines equals for you. Under the hood, it's a transformation because you're transforming to an instance of the class instead of just working with plain data, right? So like we're not doing the same thing here that we're doing here. A schema class actually creates an instance of 0.3, whereas schema.opaque is just a type level hack to allow this identifier to represent this object. But under the hood, you don't have an instance of this. It's literally just this. There's no like transformation, as far as I'm aware. Mattia, you can correct me if I'm wrong.
No, I think so as well.
And I think Mike also responded down below. Oh, it doesn't define equal anymore. Equal structural by default. You're right. But there are, like I said, that I think the transformation here is still heavy enough that justifies having opaque. But you know, maybe because we have schema.as class now, we could consider removing opaque. I don't know. It's our static members in the third example as tree shakeable as they would be if they were exported members in example 1. No, static members are not tree shakeable by any bundler.
And again, that depends then and on what the static members you are defining on and what's the purpose of your app is. Because, for example, if you are defining your domain objects as schema classes, then it makes sense to have maybe helpers as static helpers. Like, for example, like you have an user object and then you have a static helpers to get the initials of that said user. That makes sense because probably you will do that anywhere and that's tied to the domain object. Whereas if you have doing something else, like for example, if you want to do things like fetching maybe a user from a database, putting that as a static helper over the domain, again, not good because you will end up bundling that as well if you reuse your classes between like your environments, like your client and your server and whatever. So yeah, be aware of what you put in there.
Fun fact, I've managed to fix a bug on which I spent over 100 hours. The solution was to replace decimal.js with big decimal from effect. Really powerful thing out of the box. I just hope it's memory optimized. I'm glad to hear that effect solved your bugs. I think I've covered all of the Schema.Class questions. We've spent 40 minutes on this. Mike says technically they are by the closure compiler, but nobody uses that. Opaque can be used to get nicer type signatures when hovering over the code and has not defined the function return explicit. I guess you're saying the function is not explicitly, the return type of the function is not explicitly defined. Yes, but again, there are footguns with the opaque schemas as well, which Mike points out, which is like when you try to do like something like X instance of 0.2, like this doesn't work. There is no instance of 0.2. This is just a type level representation of this. So in a way, schema.opaque is a little bit of a hack, but it's literally only there to create a nice identifier, because sometimes, like, you know, point is a very small struct schema, but you could imagine, actually we don't have to imagine, hang on, it's a good example. The OpenAI client here. If we go to if we go to, where's the schema for this? It is right here. So you can imagine when you start getting really big struct schemas that have transformations and things like that, like the types start to get really complex. And like this is the type of the schema, but even so, if I did type equals type of chat completion response dot type,
boom.
Like this isn't really that nice to look at. Maybe some people would argue that it is because it's very explicit what's in here, and that's a good argument. But some people's domain objects start to get extremely large to the point where it gets truncated by TypeScript, and would prefer to have a nice, like, be able to see chat completion response instead of like the full type. So anyway, yeah, there are valid reasons why we have these three methods in here, but you know, there are footguns with each of them. We should consider how many of these we can combat with the LSP, Mattia. I don't know how many LSP rules already exist in this domain, but
for example, the one that you mentioned before about the instance of, there is an LSP rule that bans the instance of, because generally I don't like the instance of checks when there is a schema on the right, because that bounds you to having that thing to be a schema class. Whereas that if you eventually decided to change that to a union or something else, the proper way to do that would be to use schema.is, which for schema classes is basically just the instance of, but for everything else, yeah. And also like there is also another LSP rules that bans constructing schema values by using the new constructor, for the same reason, because the new constructor can be used only with schema classes, and so if eventually you decide to move away from that, you basically broke your existing code. So the proper way I usually prefer is to use the Schema.make, because that's the same. Either you have a union, you have a struct, you have a class, whatever works with that. And also, if you are inside of an effect, the correct way would be to use make effect instead of new, because that the new could throw if you have checks, for example, on string, and you provide an empty string and there is no type level guard on that, and that fails at runtime, but do not fail at runtime type level. And so using make effect is more explicit, because then it raises a schema error that's in your error channel you have to deal with.
Right. All right. As long as there are no other questions about schema classes, I'm going to move on. There was one question in Twitch chat that was, what do you think it's better to rewrite a TypeScript project in 2026? Rewrite it in Effect or Rust? What nuances have changed, especially talking about agentic coding? Well, if it's a TypeScript project, I'm not sure you'd want to rewrite it in Rust. If your team is more familiar with TypeScript, it's going to make it a lot harder to iterate on that project. Even in the world of agentic coding, I think there's always going to be a role for the human in the loop. In my talk in Miami, which again I'll give at some point during an office hours where we have nothing going on, I talk a lot about the future of software development, moving away from this like local dev loop, and even in that world, how important the human in the loop will be. Obviously, I'm biased, and I think effect is very powerful for agentic coding. So my argument would be, if it's a TypeScript project and you're rewriting it anyways, try effect and see how it goes. There are plenty of other folks on social media who would agree with me. So anyway, and Mike makes a good point in the chat also. Rust is not really an alternative to effect. You don't have dependency injection, telemetry retries, etc. out of the box. Yes, you can wire them in with different Rust crates, but it's not part of the language by default. There are other benefits to Rust, but it's like, I think that there's like this mind virus that rewriting something in Rust by default makes it better. And it's like just not the case in my opinion. I think for IO bound apps, there's a real value in writing it in a language that many people are familiar with. If you need native performance, then my personal preference is Rust. I think the type system in Rust, if you're building something in a native language anyways, I think the type system in Rust and the semantics of the language are really powerful. The fact that like you don't need a garbage collector in your binary is pretty nice. Having said that, like for IO bound apps, like most of us are designing, I don't really see the need to rewrite it in Rust, right? I think the reason that's become popular in the JavaScript TypeScript space is because there are a lot of tooling projects that are rewriting in Rust, like Bun and the Vite Plus, I think, is in Rust, and all of the associated OXC tooling is in Rust. But like in those cases, it makes sense. They do want native performance there. They want very fine-grained control over memory, which you can't really get with JavaScript or TypeScript. So yeah, I think if it's already a TypeScript project and it's working well, my preference would be my preference would be rewriting it in effect, because I also think you get like the benefits of the all of the agentic coding benefits, which again I can talk about when I actually give my little 15-minute talk on one of these office hours. Okay.
Okay.
Let's
Next
talk
up.
about Eigor's 50 minutes later. Let's talk about Eigor's project. So what files did he want us to look at?
Let me check. The most interesting files are in examples, effect, src, atoms.
Effect, source, actors, chat room. Okay, hang on. Examples. Effect, source, actors, chat room.
And the other one is also Rivet, Kit, TypeScript, packages, effect, src, actor.
Rivet.
So, packages, effect, src.
Hang on, what is it? Rivet, Kit, TypeScript.
Yeah,
packages,
effect, sources, actor. Yes.
Without knowing much about the Rivet SDK, I'm not entirely sure we'll be able to provide exceptionally useful feedback, but let's maybe start from the example and then go from there.
Actions.
So let's see. We have a an error, which is a schema tagged error class. Nice that we're able to use schema by default here. Actions use explicit schemas, which enable runtime validation. Schemas validate encoded data end-to-end, which protects from malformed, stale, or malicious data. And then schema distinguishes encoded and decoded types. Values like URL, big int, or custom domain types can have safe encoded forms on the wire. You wouldn't believe, by the way, this is like such, I'm not going to get into this tangent, but you wouldn't believe, again, how many people I have to explain this to. Like, the question usually starts with, why is effect schema better / different / why should I use it over Zod or something similar, like archetype or Zod or what's the other one? There's another one. Whatever.
Zod, schema, yeah.
And my like default answer is usually, aside from the tight integration with effect and all of that stuff, like the easiest win in my mind is that you can have a safe representation of both your decoded Valabot. Thank you.
Valabot, yeah.
Yeah, that was the one I was thinking of. Thank you. You can have a safe representation of your decoded and your encoded type, your serialized and deserialized types. And it's like immediately the face that like I see the eyes go blank, and it constantly boggles my mind because I have to explain, like, okay, for the longest time Zod was unidirectional, decode only. Like, yes, they have support for codecs now, I think, but for a very long time Colin's stance was that decode only was all that was necessary, as far as I'm aware. And with effect, we took the stance that like you're not just receiving data, you're also sending data from your application. And so you also want to have safe serialization of information going out of your app. And again, like, I don't know why, but it's like half the folks that I talk to, it's just like eyes go blank. I get this weird stare, like they're looking at me like I have 10 heads. And I have to be like, listen, if you were a Rust developer, this would be like, yeah, that makes sense. The most common like Rust's serialization to serialization framework, CERD, it's literally in the name.
Serialize, deserialize.
From Mike, I had this conversation with Colin from Zod, and he wasn't really getting it, and then he started working on a product, and by magic, the encode side was added to Zod. Yeah, all of a sudden, codecs became a thing. It's like, oh, yes, okay, this makes total sense. Yes, you want to be able to safely encode. JSON stringify is not enough. You need to be able to serialize information going out of your app.
But also every time you read something from whatever storage you have and you decode that, whatever IO boundary, that's storage, HTTP API, whatever, you first, yes, you have to decode it, but eventually you will need to send that back. And without that, how would that send you back?
I constantly,
it's something
like,
that,
I don't understand what it is, but like, it does not compute. Like I'm not gonna say names or anything like that, but I had this conversation with at least 5 different people when I was like traveling for the meetup, and it took like a substantial amount of effort to get my point across, and I don't understand why. So anyway, yes, this was like this is a sensitive issue for me right now. Anyway, there are other value propositions to affect schema that go beyond just safe serialization and deserialization, but like, it's, in my mind, it's like the easiest place to start with, folks. I think from Twitch chat, I think most JSTS devs, when they think of serialization, they think, oh, it just needs to be able to be turned into a string. Not that it should maintain its shape so you can recognize it when you deserialize. I think that most JS or TypeScript devs have never implemented a protocol before, like a wire format protocol. And so decoding is fine, and that's all I need, right? It's just a strange thing, especially when, and I think this is not a knock against Zod or anything like that. I think that when a library like Zod becomes so ubiquitous, and it's only concerned with one direction, the community that has become like totally encapsulated by this library, the ubiquitousness of this library, lends itself to the way we think about dealing with data. And it just, I think that might be part of it. I don't really know, but again, if you talk to like a Rust developer, it would be, yeah, of course, that makes sense. I got to serialize my data too. Like, anyway, moving on. I'm adding fuel to the fire. Yeah, you are. So, stop baiting me, chat. God. So it looks like we're able to define actions here. So initialize, this action replaces passing an input when creating an actor. So we have a join action. This looks very similar to like the RPC and HTTP API, like spec definitions. So I guess these are just actions you can send to a Rivet actor, I'm assuming, or maybe messages are the thing. No, actions, yeah. Oh wait, messages are not yet implemented. Non-completable fire and forget. Completable. So I guess actions are standalone values versus embedded in the adjective. Allows for shared action protocols. Okay, again, I'm not familiar with the Rivet.
I'm not familiar too much with the Rivet, but I would say that probably what you mentioned before about the effect RPC, probably one could even consider like reusing the effect RPC way of defining the actual effect RPC definition. Because from what I've seen in there, I've just seen basically a payload, a success, an error, and maybe some additional metadata. And one could reuse an RPC group for that.
Yeah, I wonder if there are maybe some additional properties on action.
Yeah, and I'm also wondering like if those additional things that are coded over the actions, maybe they could take place in annotations, for example, in effect RPCs. But again, I don't know much about Rivet, but yeah, from the shape, payload, success error, that's an RPC.
This looks extreme. This looks almost identical to RPC aside from this one property here. Could consider, to Matthias' point, Igor, I considered using RPC, but didn't want to diverge too much from the conceptual model of Rivet. I get that. I don't think there's a problem here. I just think this is like reinventing the wheel a little bit. like all of these type helpers and things like that already exist in RPC. Anyway,
Yeah, I mean,
it's
it's
a 200 line module. It's not a big deal.
Yeah.
I think the protocol definition here is nice.
Hmm.
Like the definition of the protocol is nice. It's very familiar to anybody coming from Effect. That like this should be relatively familiar.
Hmm.
Let's see. Actors can use custom effect services like any other effect program. You provide the service layer to the actor layer and then yield it in the wake scope. Okay. Two-layer produces a layer that registers this actor with the registry service that is in context. The first parameter is a wake function that runs once the actor awakes and returns the action handlers. Okay, so I guess here the service constructor runs during wake, and then you return the implementation that handles like the action handlers, or the implementation of the actor handlers, action handlers. Geez. I'm assuming these things are Rivet specific.
Yeah, I think so.
One thing I did struggle with here is how I expose the state primitive within the actor. I'm assuming this is the state primitive, or the definition of the state primitive.
I also seen before there was like a state module, state dot something, state dot update.
So,
I've seen state dot changes.
Yeah, there's a. So I guess one thing that you might consider, Eigor, is reversing the ordering of this into layer, because state will not be type safe until you've actually defined state down here, the schema for state. So one thing you could consider to make sure that this is type safe at the point that you start implementing it is putting the state and database definitions first and then having the implementation.
It is also nicer to see, I would say, because then when you jump to the definition of the chat room live, you first see the shape of the state it holds, and then you see the behavior. And seeing the behavior without having seen before the state, usually it's harder to understand. But that's, again, only how my brain works.
This closure here seems unnecessary, unless you're doing something synchronously in there. So it looks like state is a pub sub under the hood. With a semaphore. This looks like a subscription ref.
Yeah.
Correct me if I'm wrong, does a subscription ref have is backed by a semaphore by default in V4 packages?
I think so. We could check, but I think so.
Hang on a minute. Yeah.
Yeah, there is a semaphore. Yeah.
You're basically implementing a subscription ref here. Like, I almost think your state thingy could just be a subscription ref. Like, we have changes already in a subscription ref module. There's the concepts of like writing and things like that to the thing.
Unless when you make, there is scroll down, unless there is like interceptors that are called before writing, and that could be something like I write and then, because there is in that make, there is like a read and a write, and if that write is called before basically publishing, basically
so Eigor says it tries to replicate subscription ref. I think this is to your point, Mattia, as I couldn't use it directly because I needed to wrap the Rivet SDK underlying c.state API.
Yeah.
Can state just be a service? like that you get access to, I guess you can't do that because you need the shape of state to be taken from the layer definition.
But again, if you move the state definition before the handler, you could then pass in the argument of the effect of an handler, something that wraps that state with something that's not a service, but it's still like an instance of something that has built in those methods for subscribing or writing or whatever. Also, I've seen that write, that there is basically a write and a read interceptor, if I understood correctly, in that state. Yeah. So that means that every time in your Rivet actor you want to change the state, you are basically intercepting that and adding additional error to the state.set, for example, if I get correctly. Correct me if I'm wrong, if I am making wrong assumptions.
Also, you're in an effect here, so you don't really need to unsafely create the semaphore. You're also publishing unsafely, which you don't need to do if you're in an effect, unless there's a reason for this. Igor says that's right. Those are underlying those are the integration points for the underlying SDK.
Yeah. So basically, Rivet is intercepting every time you write the state and persisting that, I would imagine, in an event journal or something like that.
Personally, if I were you, I would get rid of the state module entirely and attach all of these methods to state. Because there's really no reason for this module to exist.
Yeah, you cannot access state outside of the handler, so it does not make any sense to have a module, I think.
I would define state first in my 2-layer method so that state is type safe. And then I would make state an object with methods that allow you to read the current state, write to the state, get the stream of changes, etc., etc., etc.
Yeah.
Because, yeah, there's no really, like when you have APIs like this, where you're passing in like a piece of information that you're going to then like use to access other things, like there's really no need for the consumer to have to import another module to use that thing.
And probably the raw Rivet kit context that you had before in the parameters, if that's untyped, and I think so, because from where it appears, if that does not have anything typed against the current like events that the chat room defines, I would put that as well in a context service.
Yeah.
If that given, if that does not have types that are.
Yeah, if there's no dependent types here, like if this is not dependent on anything else that you're defining here, I agree with Mattia. This could be the raw Rivet kit context could instead be a service that the consumer yields if they want to have access to it. Instead of being passed in as a parameter here, you basically have like a const Rivet kit equals yield, or Rivet kit context equals yield Rivet kit context, and then you can use it if you want to. Just like to keep as much as possible consistent with effect APIs. Like obviously state is determined by the types that you define, so you can't do that, but yeah. What would be the benefit to making it a service? In this case, like there's not necessarily like a benefit, but it's more like semantic for effect to have this exist in a service. Plus then you can mock it easier in tests if you need to.
Mostly for
instead of
testing, I was thinking. Yeah.
instead of having it come in through the method here, which then would require you to have like probably custom like 2-layer test things, which again like is kind of annoying. Instead, you could just have a test service that you pass in for the Rivet kit context. Unless there is some limitation, the DX I expect is to yield the state. I expect to yield the state and be provided, and then I use the modular methods on it. The limitation is keeping the state type safe, which we were discussing. The state has to be type safe over the custom shape that you define, which wouldn't be possible in a service. Then you would have to have like this whole like accessor pattern thing where you have like a state.update state, and again like this, just then it starts to get back to the same position we are right now, where instead if state is a thing that comes in through the function arguments here, it can remain type safe as long as the state is defined first, and then the methods can just live here. Rivet kit context is type safe. Yeah, but is it type safe over something that you define here? Right? Is it type safe over some user defined piece of information? Or is it type safe like just the shape of it is type safe? Like the reason why we're saying the state makes sense to pass in as a function argument is because the user is defining the shape of their state, which then it would be impossible for us to keep type safe if it's passed as a service. Whereas if the Rivet kit context is, its type is derived by the state definition. Well, yeah, then in that case, it has to come in through the function arguments.
Okay.
You could also remove it as a separate object and just have state.context. Like trying to keep the API minimal. I don't know. State.rivetkit context, state.context. It's all debatable. I don't know the API as well, so I don't know like.
Also, the return that you are having for the handlers in here, basically you need to, if we scroll up to the beginning of the definition of those handlers, in here you are basically creating a new chat room off. So basically this is a layer that is constructing a service whose methods then are the handlers of the state. Okay, yeah.
Federico asks, isn't this the same thing as having an HTTP server request defined in userland and you can yield because you defined it before? No, because HTTP server request is not type safe on the request shape. It is just representing the server request. It is not representing the user defined type of the request. Whereas with this, the state is defined, the shape of state is defined here. It's user defined. It's not like it has a very specific shape, and to keep it type safe, it has to come in as a function argument. It can't be a service. I mean, I guess you could do some like weirdness in this method where like, I have no idea how it would work on the type level because the tag can't be like you yielding the tag has to carry the type information, and you don't know the type information until the user defines it here. So there's like, I'm not sure how, I don't think that's possible. I think keeping it as a function argument makes sense. Anywho.
Also, one last thing, maybe it's not because I'm not too familiar with Rivet. I've seen that in the end of the live, you had members such as name. If you scroll down at the end of the file, there was like a name and icon, which...
I assume this is for Rivet Kit's UI.
Yeah. So I would have expected those to, at least the name and the icon, to live in the definition, but maybe that's like my way of reasoning about that.
No, that's a good point.
Because I wouldn't like expect if there is a chat room, unless there let me rephrase it. Sorry, today is not one of those good days. I'm good at explaining things. What I'm saying is that name does not depend on anything that's either the state or provided a constructor time for the Rivet kit actor. And so given that's basically static and it could be only a chat room and the icon could be only comments, I would expect that to live in the actor definition.
Looks like
Because
even
that's something you define and that's late. Unless those are something that could depend on the internal state and do things like the name updates itself, and so you define that as a lazy function that takes in the state and returns the string. But given they are like fixed, I would have expected that to live on the definition. Because then in testing, you keep the same definition, you just swap out the behavior with mocked one.
Yep. No, I agree. I think it makes more sense to have it on the spec. My thinking
because
is
you
that
already
I keep.
identified that. Yeah.
I think the thinking is, so Igor says, my thinking is that I keep the configuration that shouldn't leak to the browser client on the 2-layer side. The actor definition only has configuration that's both used by the client and the server, not the implementation details. I think that's fine. Again, like Mattia and I are just providing suggestions, but we don't know the like full picture. So take what we say with a grain of salt. I think I do want to get to this. Somebody else asked for feedback in the office hours chat, so I think we can sort of like finish up our Rivet kit. I think this looks good, Igor. I think there are like a few things that could probably be tightened up, but I think overall it looks pretty good. I would really look to see if there's a way to eliminate this state module entirely and rely on SubscriptionRef if you can. If not, like, just it feels weird to have to redefine everything. But yeah, let's go to the one last question we got, which is from Jay in Discord asking, let me just paste this message into Neovim. So the question was, let me do this. So the question was, I am modeling a protocol URI string with effect schema. It's a string composed from smaller schemas. There's a scheme, and then part A, and then an optional / part B, and then an optional / part C, etc. Each part already has its own schema. Some parts normalize on decode. The current approach is at URI from string is a codec from string to a structured value. At URI is a union of valid structured shapes, part A, part B, part A, part B, part C. Parsing uses the template literal parser and then transforms parsed parts into the structure. Is this idiomatic effect schema shape for a public API? Alternatives we're considering branded string only with parsing separate, one struct with optional fields, Schema.Class, Data.Class, custom parser transform. Let's look at the implementation. We have a union of the different valid template literals. So this is the parser. We've got a codec, which goes from at URI to at URI encoded. I think this type, this is fine. Just be aware that in, can you hear the, before I keep going, can you hear the lawnmower outside? Or no?
Oh, probably it's mine, probably.
No, it's, I'm asking if you can hear the lawnmower outside of my house.
No, No, because I have another one outside of my house as well. So that's why I was asking.
If anybody can hear the lawnmower outside of either of our houses, please let us know. Otherwise, I'm going to just keep going. No lawnmower.
No,
Great.
no, nice.
So this looks fine. One thing to be aware of is that when you do annotate types with Schema v4, you lose. So Schema v4 has 14 generic type parameters. When you annotate a type, you lose all of that extra information. That being said, I tend to annotate my types if I know I don't need any other information other than, like, for example, what's in the codec here. So it's a trade-off, right? If you don't annotate your types, TypeScript has to do more work to infer them. And Schema does have a lot of generic type parameters, but you do lose some information. So just things to be aware of. Okay. I think you can brand this. No, maybe you can't. No, it's a union.
I would say something maybe more drastic.
Okay.
I would say that probably if you look at the implementation, basically we have 3 different patterns for a new URL, and we have like 3 different objects that matches like those 3 patterns, and then we have in the end a transform that converts the union of the first 3 to the object of the 3 that you can get. I would say that probably what I would do, that's up for discussion, but what I would do is, instead of doing the manual transformation in the end, what I would do is already define the entire @URI from string as an union where each member is a template string literal that converts to that specific structure. So that way I don't have to manually define the transformation, because given the union's attempt to first pick the first member, and if that conversion fails, that bubbles up down to the other ones. If we have probably a union with the 3 members, with the first one being like the most complete one, probably we can get a way of having this schema that basically takes a string and returns, which is the URI, and returns that structured object in one go without having to fiddle with manual transformation. Not sure if it would work, but that's my way how I would think about it.
No, it's a good call out. I kind of agree. Mattia's got an interesting idea there, where instead of having like the separate union for the parser, the URI, and then the conversion, what if you just define a schema union where each element defines its own transform? And then you could potentially extract like common pieces of logic from the transform. I mean, this is fine. Like, this is all of this is fine. Nothing here looked crazy to me. But yeah, that's another potential way that could simplify this a bit, is defining transforms for each one of these. And then, you could have separate schemas for each one that you union together. Might just make things a little bit. I think I follow what you're saying, but I might need an example of what that might look like. Having a hard time visualizing. It would literally just basically be like extracting this template literal parser, this template literal parser, and this one, and then defining the transform attached to each of them into your final data structure. So you would have a transform from this to this, a schema that is a transform from this to this, and a schema that is a transform from this to this, and then you would union them together to get your final @URI from string schema, instead of having this union, and then also having this transform method, because then you could define the logic.
The logic becomes trivial, basically, because you are just mapping position 0 becomes an object with authority. Always, there is no condition of the length or whatever. You are just saying if we match the last entry, we just take the matched entry and becomes an object that has just the authority key, and the value becomes that entry.
Yeah.
And so you don't have
to do,
that. Yeah.
You don't have these checks. We don't have all this conditional logic. And you could extract the getters as well, like into individual methods. So like you could basically define, so in schema, in effect, in v4, if we go to scheme, actually, let me just do this in Neovim, it'll be easier. Schema transformation, you'll notice that we tend to extract common transforms into shared. Wow, there's a lot of types in here. Hang on. Let's just look for big int from string. So you'll notice here that you can extract transformations like into a shared variable that can be reused. So you could even do this, right? You could clean up the actual definition of the decode to even further. So every single case becomes a full spec from string to structured object, and then you just union them together. It might not work as well as we think in our minds. Like we'd actually have to like implement it to see, but yeah, like it could be a way to clean things up a little bit.
It is something that in my mind makes like more sense about how you reason, because then you basically collocate the encoded and the decoded shape together, because you see the object that you produce with the template you have basically in the same piece of code. Whereas doing that as you are doing now, you are basically having all of the encoded, all of the decoded, and then the transformation, which again probably is fine with only 3 cases, but if eventually you need to support like 5 or 10, that probably become more messier.
I was gonna like try to do it in line here, but it's like a really long, I'd have to copy over a bunch of code and I don't want to do that, so sorry.
Just send your flanker to do it.
We have one last request for code review. The question is, let me see if I can like copy paste this one. Will this work? Let's see if this works. If you have time, how would you add headers to an HTTP API error response? For example, for a too many requests error, we want the response to be a 429 and include a retry after and a cache control header. The error is currently modeled roughly like this. Right now, we can handle it at the route HTTP boundary. So catch tag, the response, JSON on save, cause, status 429, and then we add some headers. That's not very ergonomic because every handler, wait a minute. That's not very ergonomic because every handler has to know how to encode the error into HTTP. Every handler has to know how to encode the error into HTTP.
Basically, I think what he's saying is that based on the error type, he always sets some headers, and I think it's asking for a way so that every time he wants to raise that error, those headers are automatically added without like having the user to do that at error yielding location. Is that
Got it.
correct? Is that correct? First, let's assume that our question, the question we got, is what we're asking.
Matteo, we're always correct. Let's be honest here.
I don't remember if in the HTTP API schema there is something for that. I recall that there is a way to set the error code, but I don't recall if there is something to set. Let me. Yep, the question is that. Yeah, that's the question.
Response headers to add custom headers to the outgoing response. Call HTTP effect to append pre-response handler inside your handler. The callback receives the request and response objects. So I guess this is one option. I don't know if this fully satisfies the answer. Pre-response. Request and response objects and must return the updated response.
Yeah, one way I think could be that one, to add a custom interceptor that intercept what are you sending back, and then appending that based on that.
Let me see if there's anything in here for error response headers. So by default, when a request fails, schema. Oh no, this is schema validation. This is schema validation. I don't know the answer to your question.
Maybe you could do that with a middleware, maybe?
I feel like we should have an easy way to do that, and if we don't, that's a problem. So I will ask, I'll ask Julio if there's a pre-built way to do this and post it in the office hours channel, or maybe I'll even ping him in there. And if we don't have something simple, then I'm sure we can figure something out, because it seems like a common case that you'd want to have response headers that are specific for errors to be able to attach information in that particular case. First time I hear that, damn. Man, you should join our Slack. You'd hear me telling everybody that I'm wrong all the time. Going back to the @URI thing, Luex, I think the question is, should I, instead of a struct, should I use Schema.Class or Data.Class or whatever? I think it's kind of up to you about like what type of API you're trying to expose. But like, if I was going to use a class-based API to expose additional information to my end user, I think I would favor Schema.Class for tighter integration with Schema, since you're already using Schema. I'm mostly looking to sanity check that I'm not crazy. No, it's good. It is impossible to keep the entirety of the effect APIs in your head all the time. So there's maybe something I'm missing. But let me ping Julio in here now. Let's create a thread. And let's say HTTP error response headers at GCanty. Do we have an easier way to set headers for error responses in the that cool.
Yep.
Is effect workflows a replacement for PG boss? I haven't fully wrapped my head around the differences. PG boss. Gotta look this up. Queuing jobs in Postgres from different concerns. Looks like PG boss is a library for using using Postgres for queuing functionality. Job queue built in Node.js on top of PostgreSQL in order to provide background processing and reliable asynchronous execution. No, workflows are for building durable workflows in TypeScript. Usually, and you need to bring your own engine. So we have a pre-built engine for effect cluster. So if you're running an effect cluster, you can use the cluster workflow engine for running your workflows. But no, these are slightly different or pretty different use cases.
By the look, PGBoss seems more similar to the persisted queue module of effect, which basically allows you to define a persisted queue and then have consumers that pick up jobs from that queue.
24-hour cluster stream when? It's funny, Mike asked me the exact same question yesterday in Slack. Can you use Schema.Class with such a shape where it's type safe and has optional parts that depend on the others? It seems like I'd have to wrap the type because those APIs require an index signature. You'd probably need 3 separate class definitions that represent each object shape, and you would transform into them. Or you'd have a class definition where certain fields are optional, for example. All right. Well, it's been an hour and 40 minutes almost. We spent 40 minutes today talking about Schema.Class.
45 to be more precise.
That's good. Hopefully people got a lot out of that. We may have a special guest next week, so stay tuned for that. More to come there. But yeah, thank you all very much for attending. Hope you all enjoyed the stream, and we will see you all next week. Cheers, folks.
Cheers, folks.